Let's do another one. Now this time they're recommending something to us. They're going to say an object moves along the x-axis with a position at any time t greater than 0 is given by the function x of t is equal to cosine of t squared plus 1.
This is example 3.
This is example 3. So now we're going to apply the chain rule. So I'm gonna do this on purpose. We're going to do the easy way first, and then we're going to do the long drug out way. Eventually, you guys will just do the easy way. Okay? So the easy way is this. What did I say? Derive the outside first. Right? So I'm going to say x prime of t.
Cosine.
Well, what's the derivative of cosine? Negative sine.
Yeah.
Sine of the stuff.
T squared plus 1.
The stuff. And then what do we do?
Take the derivative of the middle. 2t.
Take the derivative of the stuff on the inside. What's the derivative of t squared plus 1? 2t. So I tack that on the end. Now I clean this up a little bit. This is a convention that we do. We say minus 2t times sine of t squared plus 1.
2. Got it. 2t.
That was pretty easy, wasn't it?
Yeah.
I'm not done that.
Wait, what?
So
the whole thing is
x
negative.
equals
Mr. Auto,
Yes.
you multiplied it. Where did the negative in front of the sign go? In front of the
it's
sign.
in front of
It's in front of
Oh,
the
So the
okay,
whole,
okay, I
the
see.
whole
Never
thing
mind.
is,
I
it's
see, I
not
see,
negative
I see.
sign, the whole thing is negative.
Sorry.
So
Yes.
The equation.
So you just do
why'd you rearrange it?
So it looks prettier.
Yeah, I like it to look pretty.
No, it's
Yeah,
not.
you thought
but
about
it doesn't. But
It
in actuality,
always
it doesn't
is.
matter to these bonds.
Mathematically, it doesn't matter so long as you remember that you're multiplying by this.
Okay. Yeah. Okay. That's.
Which one do you?
Although this is the convention, right?
I don't.
Well, which one would you would multiply sine by the stuff in parentheses first, right?
Yeah. Well, let me show you something. I'll show you another shortcut without all the du, dx, all that. Another way you could do this problem is you could say x equals cosine of u, where u is equal to t squared plus 1, u prime is equal to 2t. X prime is the derivative, well, we could write it like this. Dx, actually, I want to use this notation. So, you know, x prime would be, what's the derivative of this? Negative sine of u. Now, here's one thing that we haven't done a lot of. I need to let you know that this is a derivative of u, so I would write u prime on the end.
U and then u prime.
Yeah. And so then when you plug that back in and make it a function of t, you would say negative sine of u, t plus 1, and then times 2t.
Wait, what?
Where'd you get the 2? There it is.
So you multiply. Okay.
It's the same thing that we did before, just different notation. This notation, the prime notation, is a little more common when you do the chain rule, because it's less stuff for you to write down.
Oh, you just put it there so then you can just plug everything in.
Yeah.
And then it
Yeah.
So you're just multiplying. So when you have x prime, that's obviously the negative sign u, and then you're just tacking on u prime.
Yeah.
Okay.
It's just that all the problems that we've done in the past, u prime has always been 1.
Yeah.
Every time we've done, and you guys don't realize it, but the author of the textbook is purposefully, all of your homework problems, u prime has always been 1. So 1 times whatever this stuff just gives you the derivative.
What if Khan Academy guy did our
I'm not leaving my kid u prime. What?